first lab that we're going to be doing together, but not really together. We are going to be investigating a constant acceleration and a constant velocity. So I'm going to send this marble down this track. So we've got an inclined portion of the track and a horizontal portion of our track. So I think we would all agree that when I send this marble down the incline, it's going to speed up. And when it moves along the horizontal portion of a track, it will move with a constant velocity. So we've already talked about distance and displacement, speed and velocity, how we're going to be describing motion for the whole year. There's going to be 3 different ways we can describe motion if something is at rest, if something is moving with a constant velocity, or if something is moving with a constant acceleration. Those are the 3 ways we're going to be describing motion. So when you are presented with some scenario, you have to identify which of those 3 is it going to be, and that'll help us continue to describe or put some equations on the scenario that we're doing. So for right now, we are going to be investigating constant velocity down the inclined plane. So I've already marked off with my meter stick a full meter. So we're going to start, my position 0 is going to be at this first mark. And then from there I marked off 25 centimeters, 50 centimeters, 75 centimeters, and then this is 100 centimeters at the bottom of my inclined plane. And I lined it up with my horizontal section. So at the 100-meter mark, my marble will start moving horizontally, 125, 150, 175, 200 centimeters. So my marble will be moving a total of 200 centimeters, which is 2 meters. Half of which will be at a constant acceleration, and the other half will be with a constant velocity. So the data that I'm collecting is going to be the time it takes to go these displacements. So I'm going to run this marble down 4 different times, and then I'll go back and look at the video and use video analysis to see, all right, how long did it take the marble to move from position 0 to position 25 centimeters. So I'm going to look at all 4 trials and write that down in my data table. The second set of data will be from 0 centimeters to 50 centimeters, you know, the 4 different trials, write it down in my lab notebook, and then the 4 different trials from position 0 to position 75 centimeters, position 0 to position 100 centimeters, and then I'm going to do the same thing from 100 centimeters to 200 centimeters. I'm going to keep them separate because the ball is accelerating for this portion and moving with a constant velocity for this portion. So I'm going to keep them separate in my notebook. We're going to analyze them a little bit different, make some graphs, but for right now we're just collecting the data. So I'm going to put the marble down starting at position 0. I'm going to run it down the incline 4 different times. The reason we're doing 4 different times is so we can take the average time it takes to go 25 centimeters, the average time it takes to go 50 centimeters, and so on, so that I can have a reliable set of data. Also, if one of them, the data sets looks a little askew, we can toss it out and collect another set of data. So the good thing about Physics 1 is that all the data collection is super short. So there's no reason why you can't collect more data to have some more accurate readings. So without further ado, I'm going to send this ball down, and that will be that. And then we can come back together and take a look at our data that we collected. That's it.